Alrighty. I think we're good. Check levels. Levels are wonderful. Great. Cool. Yep. Alright, welcome to the stream, folks. Another week. Another... More Haskell action. So, I'm Agent Ultra. Welcome to my stream. I'm going to be hitting you tonight with some Haskell. I'm started a project a few streams ago to see if I can build a multi-user dungeon or MUD server. And it's like a multiplayer game server, text-based, where multiple people can connect and interact with a fictional world in real time. Or soft real time, anyway. As best as possible. We're going to learn a lot about networking and Haskell's concurrency libraries in this one. So, yeah, buckle in, get cozy. If you have any questions or want to take a little diversion, show off your project, or have me explain something that you're not familiar with, that's all good and welcome. So feel free to just chime in and chat whenever the need arises. Without further ado, though, let's dig into it. I've done a little bit of hacking on the project, I guess, as I've been going along. Starting to try and clean things up a little bit. Get things going. So not a whole lot has changed. Let me just go through the commits here. I think basically I added a broadcast channel to all of the clients that connect. So there's one broadcast channel for the server to use, and that's just to send out broadcast messages to all the connected clients. That way we don't have to iterate over all the connections and insert the message into each out channel for each individual connection for those kinds of things. Should help ease a little bit of memory pressure there as well. Probably not going to be a huge issue, but yeah, broadcast channels. So these are like a special data type called a tchan in the STM library. Right, you import them control.concurrent.stm.tchan there, and just like a TBQ, it just takes a parameter of what type it's going to hold. It's going to put text for now, and yeah. And so we set up the broadcast channel in the main server state that it holds onto, and then whenever a client connects, we add that broadcast channel, or reps to that broadcast channel to that connection. Which is pretty handy because then we can have a little function like this where it can ask for that broadcast channel and we can just write a message to it, and all of the clients that are connected will get that message. And so that's what's now powering the simulation, little fake simulation we have going right now. That's just broadcasting out the message hello to all the connected clients. Pretty handy. So we're going to be doing more and more stuff like that. I think I'm going to be working on getting the command dispatching going tonight, and maybe looking at logging again for the server. I figure out how we're going to do that and get that going. So got a few directions to go in. So client, this module here, server client, is kind of where I'm going to put the code to talk to clients from the server. Like when the server wants to talk to a client, you can use broadcast to all clients and various other bits and bobs. And let's do, what do I want to do? I want to do the thing I was gosh damn it, brain. It's right on the tip of my tongue. Yeah, you know what? I'm going to open up more code and I'm going to take a look and realize what I want to do. Yes, command dispatching. That's right. So I'm thinking maybe I want to put command dispatching, maybe not in client. Maybe it should be in under server though. And so the idea is that we have something that's, each client has a thread that's reading off of its input queue. And we have to do something with the input queue, right? The server needs to react to the client's input, right? The commands the client sends us. Now, there is a saying that, like, you should just make the game you want to make, don't make the framework. Right? And I kind of want to make the framework on this one. Hopefully, mainly because I want to experiment with the design of the engine itself, separate from the game, and show more of the, or learn more of like the Haskell libraries and get to use them a little bit more, like STM and networking and things like that, without tying up all the game logic too much into it. Because I also want to like experiment with the Lua bindings, so you can write your game logic in Lua, and Haskell's just going to take care of running and executing everything. So command dispatching is going to be really, really important, because the user, the person writing the mud code in Lua, say, to design their game, is going to implement their own commands, right? For their game. So they're going to want to, you know, be able to parse input and write their command parser and things like that. And we just want to take whatever that is and react to it. Right? So yeah, command parsing. That's actually going to be kind of hard to do framework-y wise without having the Lua mud code stuff all set up as well. But there are some meta commands we need to implement. Like, we got to be able to, when clients connect, they should be connected at like the minimum amount of authorization possible. Like, they shouldn't be able to do commands that change the server or anything like that until, one, they authenticate and then get permissions. We could have some basic commands for interacting with like other server-y type things, like just getting the greeting message again, quitting and disconnecting, things like that. Maybe we can even make the tell like a chat type system built into the server part as well, and then dispatch anything else to the mud code, to the Lua user scripts for further command parsing and processing. So why don't we try experimenting with that and see how that goes. We'll put them in here. A module Bakamud .server command. All right, so a command can be either a server command, we're gonna go server command for now, and user command. What am I going to name them, though? I want to kind of put more stuff in here, because there's going to be a bunch of different server commands. Maybe we have the login command. User command isn't a good name. Login, message of the day. And otherwise, unprocessed. It's not processed yet by the user code. I don't know. I'm not sure if I like that name. But I'm gonna put it there. Okay, so for the login command, that's gonna take some parameters. Alright, it's gonna have a username, say. And I don't know if the password processing. Username and password. Yeah, we'll have to make sure the UI, of course, follows typical conventions for this. So that we don't, you know, show anybody's password that doesn't want it to be shown when they're logging in. That kind of thing. Message of the day is just message of the day, no parameters there. And unprocessed, we're going to just make that text. Alright, so we got to import the type for text. Okay, not tax, text. Right. And username and password types. These. Where should we put those? Let's put them here for now. I'm just going to new type wrap them. Pretty good idea to new type wrap passwords too, so that we can have our own custom display instances for them. So we don't accidentally show passwords in logs and things like that. So we can't have show instance on command because we don't have one password. So that'll be kind of annoying for debugging. But we could, once we make a show password, show instance for password, we're just going to customize it so it doesn't show the actual text. I'll just replace it with, like, I don't know, stars or something. This instance, I think it was like this, if I remember. I might have to look it up, but we're going to ignore it. Yeah, we're just going to return password. Hopefully that's fine. Okay, so that's good. All right, so next we need a way to, like, when the user gets to receive that input, parse it, and get a command. Okay. So, let's see, where we're gonna put this part. We're gonna have a parser here. Why not, right? We need a parser library, parser combinator library. There is a built-in one in the base standard library. It's not super great though. I had built a whole compiler in it once. Don't recommend, but it's possible. Okay, so I usually use autoparsec for a lot of my parsing needs. This usually works on byte strings, can work on text. It's not quite as fully featured as a library like megaparsec, but it's nice and small. So it says a fast parser combinator aimed particularly at dealing efficiently with network protocols and complicated text or binary file formats. Maybe megaparsec is also good. Megaparsec, the reason why megaparsec is a little bit better for Haskell is a little bit, well, not better, but different, is that it's very feature rich. And you get better higher quality parse errors, which might actually be more useful for this project. It's just a bigger package to compile. Yeah, let's go for it. Let's try. If it works for us, it works for us, and that's good enough for me. Okay, library, MTL, megaparsec. Let's see, what versions we got here? We're on 9.6. I think 9.7 ought to, hopefully will compile on it just fine. Let's get our builder going. Okay, so that's going to start downloading and building all that stuff. So we need text.mega parsec. Down here, maybe? Okay, and we also need to update our develop file to have our new module in it. Okay, and now we're going to write our parser. Command P, convention. I think the type is parser. Parsec, they call it, okay. Expecting more, okay. Don't know this library super well, but they all roughly work similarly. Oh, you get a custom error component, okay. Type parser. That will be useful when we want to do custom error messages and types for at the parsing stage. Void. Why is it void in scope? Sorry, Google. It comes from data to void. You got to import it. Cool, cool. Parsec anymore, parser. There we go. Okay. So we got a hole. We can get our parser. So what are we gonna do? We're gonna try a login command. We're gonna try 3 different parsers: login command, message of the day, otherwise unprocessed text. What's our alternative operator here? Combinators. Where are all the combinators? Spam, 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 spam. It will never end. You're gonna be reported and banned. See you later. Okay. That's it? This is all we get? Oh, it can't be that. One of, none of, chunk, label. Oh, okay, just use alternative? Okay. Ah, there, that's what I was looking for. So we get login command, parser, or message of the day command, parser, or unprocessed parser. Don't really need to do there. And we just pop that on the line there. Those aren't defined yet, so we're going to define them. And unprocessed. These need to be all fixed. And have a space in between. There we go. And that just needs the command there. Okay. All right, now what do you got here? No instance for stream command arising from use of. Why do we need a stream instance for that? Oh, no page for that, huh? Docs are borked. It's okay. We can find out. There's a way to make GHCID evaluate comments. Allow eval flag, yeah. So I should be able to, what is the syntax word again? I think it is something like this. That's parser. Yeah, 1 + 1. Okay, yeah, that's kind of what we want. Okay, it's gonna hello. Okay, cool. So I want the info on this guy. That's not gonna let me. Okay. That's more of a GHCI kind of thing. do that. Just load here. There we go. Okay. Data, it was text.megaparsec. That's defined as an alternative in base. Right. So, what is happening? With this cat. Okay, that's got to come from somewhere. We need try for that. But is that the claim? The link, at least in the package, claims it's from megaparsec, but that's usually this operator is also, like we're seeing in the REPL here, defined in base as alternative, which is part of applicative. Just interesting. We're going to try logging command, or we're going to try message command, otherwise unprocessed command. Okay, still harping on stream. Okay, megaparsec re-exports this. Inputs that can be consumed by the library. Types of string text and all that. So I gotta implement this class for command. Maybe I'm not using this quite right. Okay. Maybe one parsec T. type of the input stream. Oh, I see. Okay. That's what it is. That. There we go. Okay. Okay. So now we have our command P processor. Great. Let's define our parsers for, say, login. First thing we're going to get is login command is just a string that's going to look like this. The user is going to type in, without the quotes, login foo bar. It's typical, something like that. It could be a multi-state thing where we could do like login foo, and then it does a separate thing to that we can send the proper terminal codes to tell the user's console or application that they're entering a password now. So yeah, I don't know how we're going to implement that. But yeah, it could be like login foo like that. It could be like that. Yeah, let's implement it this way for now, like login foo pass like this. And we'll make it better in a future iteration once we know more about what we're doing. So the first thing is this keyword login is going to initiate the command. So that's we're going to match the string login. Then we're going to match a space. And then we got to take the username. As some combinator there. Then a space. And the password. And then we can do our command. It's not in scope, but we're going to figure out what that is. Yeah, string foo. Will they define it? Oh, it's in text-megaparsec.char. Okay. Oh, it's actually going to parse it as text. How do I get actual text to make a parsec and not strings? Cinnamon for chunk. Okay. Do I might just need to implement, have the language pragma for overloaded strings. Maybe it's just defaulting to string, but once it knows what type I want is. Yeah, okay, there we go. Okay, and then is there any other helpful combinators actually in char that might help us out? The space char, okay. Symbol, separator, one character name. Sequences of characters. Okay, so we want many until space char. Okay, so we're gonna change that to space char. Char. Many alpha numcar until space char. These should be text. Okay, mega parsec. I would like you to parse into text, not into string. And this is not what I want. But I can, I guess, do it manually. Okay, and then we just got to take that packet. Oops. Silly. Okay, we're ignoring the output. I'm just being explicit about that. Oh, gotta do that for space char too. Gross. Okay, there's our logging command parser. We pop over here. Right, okay, so then we can run it with run probably something something. Parse test. Okay, I gotta apparently set overloaded strings in the REPL. Okay, so we're getting this little error here, unexpected B, expecting white space. I guess many till space car doesn't consume the space car. Unexpected end of input. Guess we don't need a many till on that one. Probably a mini one though. Okay. Take while P might be the best. And take while 1P. That's what we probably want. Take while 1P. Name for a single token in the row. Nothing. And then a predicate. Okay, so we need like an is alphanumeric. Maybe good old data.char ones will have what we want. Token of S. Oh, satisfy. Satisfy. Interesting. Oh, okay. Those are the slow ones. Okay. Probably should do that for this one too. Just get rid of that, that. And we'll pack it here. Did it not text.pack? Maybe it's text.unpack. There we go. Okay, a card, a bool. Yeah, that bool there. It's good. So data car will have those. So we can is print there. Yeah, we can say is alphanum for usernames. And then we still have the error here. I think it is pack. 37, couldn't match type text with car. Couldn't match type with text with string. We expected a parsec T string. We get a parsec T. Void text, identity, tokens text. Why are we expecting string? Do I not need to pack it? Maybe it was just a silliness on my part. A misdirection. Okay. There, finally. Alright, we figured it all out. There we go. So, we should be able to... There we go, get our login command. And that's our show instance there as well for password. Looks like we should probably put some braces, parentheses around that. Cool. So that's our login command parsing going. Cool, cool, cool. Right. Message of the day is very, very simple. We just need to match that string. Does it make them forward slashes? I don't know if that's standard mud practice, but sometimes it can be. Maybe in our server it will be. So if that matches, then we just return empty MOTD. That's good. Super simple. Barely an inconvenience. And lastly, unprocessed, we're just going to slurp up the whole line and we'll pass it off to the mud code for further processing. So we want take while 1p. And every character. Is print. Yeah, that sounds like what we want. Oh, right. We're gonna grab that. Okay. There's our rudimentary commands and parsers and stuff. So we got login, message of the day, and things. So now we can do something with these, right? Now what are we going to do with it? You might ask. Well, that's a good question. So in the server, we have a thread called talk. We have a thread for output. Talk gets, it should really be like input or command input or something. We just pulled this and we just modified this slowly from some introductory tutorial code for setting up the network stuff. But this is where we get the input from the socket when the user types in some stuff, sends it to us, and we try to put it on the queue. The input queue. So something's got to be reading off of that input queue, draining it out, and doing something with it. And that's going to be our command processing stuff. Command processor, I guess. All right, it's going to read off that queue, run our parser that we just wrote to get the command, and then we're going to figure out what to do with the command. Maybe put it into like a dispatcher or something like that. or dispatch it to wherever we're supposed to right then and there. And that's the output thread. Okay. So here, when we run the TCP server, we got to get the address, we fork the simulation thread, and we bracket run the TCP IP loop. This is for new connections. So we should probably fork our dispatcher here, command dispatcher here. What is a command dispatch? I don't know. It's this. Okay, so here in command dispatch, this is where we want... It's going to do something here. We also have... So we could iterate over all the collections, all the connections, checking for inputs, and popping those off of their input queues and dispatching them here. One big thread that does that in a big sweep. Or we could have another thread running for each client. Or maybe we already have that thread, actually, the talk thread. Here. Now, this loop is constantly reading off of the socket. Right. We... I wonder. So what I'm thinking right now is if we do it that way, where we like iterate over all of the connections and try to drain all of their input queues for commands to process. Like a fairly cromulent way of doing things, sort of. But if you imagine that like maybe there's 65,000 for some reason, I don't know. Probably, I don't know if our server could even handle that many, but maybe it could. Maybe it could handle 30,000 simultaneous connections, right? It's got to iterate through all of those connections. Right, and those connections, this thread, for each of those threads is going to be putting here onto this queue. This function is going to be running in its own thread, iterating over all 30,000 of those. For each one, it's going to be popping off an element from its input queue and dispatching it to somewhere to the server somewhere for the server to process and do something with. Maybe we have like a big global command queue that our like main server loop will tick through. maybe not super helpful for the fact that each of those, either we have to hold an STM lock that whole time, which could be a long time to iterate over 30,000 connections, to do that action of popping off the queue and then dispatching the code. And then we can only do STM actions in that block anyway. Right, so what can we do? We can only really put it into another STM variable, right? And pass along the command to something else. So I'm wondering if we should maybe model this more like, instead of the connection having an input queue, maybe it's a channel as well. Another broadcast channel. No, because then all clients are going to get notified of all things. Yeah. Well, they get all the TB queue, the connection input queue is like cloned for all inputs. No, that wouldn't be good for a bounded queue. Yeah. Maybe we should just follow this design. So all we can do then is we could run the parser for each command. That's not an IO action, that's a pure function, I think. And then put that into like a central input queue for the server. And see how that goes. That does mean that we are locking a lot of these variables while this runs through. Which is why I'm thinking maybe the input thread here should have like just a global input queue for the server that it can enqueue on. You know? Instead of an individual input queue for each client. Then we would need to have it unbounded. And we'd have to make sure that like our server thread is constantly reading and dequeuing items from that input queue. We're still going to need the command dispatch function, actually. Because that thing will read off of the global queue in a loop and process the commands as they come in. And that's fine, because that just needs to do one STM transaction to read the queue, and then it doesn't need to bother anybody else. Alright, then those dispatch functions can then... Yeah, okay. I think we got it. Okay, so talk is going to need... We're going to have to... When we start up the run TCP server, we're going to need a thing. We're going to need a queue for our global queue. actually, maybe that's if the types are exported from the top level there. So we just go. I think it's just TQ. For the unbounded queues. And ooh, I can actually replace that with something there. Anyway, client connection. No, not connect here, but up here. And maybe it's like that. Okay, so we get our input queue there. And we get a client connection. We fork talk. So we're going to fork the client connection and we'll pass in the input queue. Although maybe that should be on init connection. Like we do with the broadcast channel. It's going to be a TQ of command. Command is not in scope. So let's fix that. That needs to be brought into scope here at this level. Connect, which is brought into the loop. Comes in the server state. Yeah. Okay, let's get rid of that. Also ask for it here. Server state, input queue. It doesn't exist yet, so let's go and add it. Input queue. What's a TQ? Let's import that. What's a command? Let's import that. Back to server. Uh, 76. All right, we got an argument here. We'll call it command. We'll start calling it command queue actually. That's probably a better name for it. It's coming together. Okay. So now we get that when we initialize the server state command. For initializing the state, though, we're going to need to update our empty server state. And this is where we use our new TQ.io. And line that. There we go. And Q. There. Okay, so now we need the connection from the client connection here. Put it in there, and now the client connection has it, a reference to it. So now in talk, we could probably drop the input queue. But we have an unknown message, and we do start a transaction, an STM transaction. We're going to, instead, get rid of this, comment that out. We're going to try to parse that command. Right, and that's going to come from megaparsec. We can do it with parse, which gives us an either. Do parse maybe. Run parser. Okay, what do we get if we get parse either? Okay, so this gives us a bunch of hooks for the error strings and stuff. We want to customize those, which we probably will at some point. So that seems like a fine function to use. Source file. I don't think we actually need the name of the source file though. So versions without it. I guess we can just give an empty string. Call it parsec or megaparsec. Call parser to parse. And we're going to parse our command P. Name of the source file is empty. And the input for the parser is going to be message. And it's going to get parser into scope. Text dot megaparsec. These have to be, let's that command equal. Oh, okay, cool. So we got expect to type text for parse, and we got a byte string because message, low level, is a byte string. So we're going to need some coding and encoding and decoding probably. That's all that means. Right, so we could decode here to a text type from UTF-8, say, that was what we could support. The data.text.encoding package. We decode UTF-8. And then we need to import that. Let's import it as T. Okay, so we potentially have a command here. Now we could, now what do we do? This is not necessarily command, this is either command. So we could pattern match on it. And do something, or we have write in command. So now, if I have command, I can only do SDM things. I can write to the queue, the command queue. I think there's a flaw kind of showing in our design now. Like, we're getting close. This is pretty decent so far. But, presumably our command dispatch thread here is going to be reading from that input queue. And it's not going to know which client or connection the command came from. So it's going to need that information in order to, you know, respond to that connection as well at some point down the line. Something's going to know which connection do I got to send this output to. So we're going to need to wrap that up as well in the type that we use for our queue here. Or command itself needs to keep that reference. Alright, which is going to be hard when where this is just parsing, right? Parsing the command. So we could create a wrapper type around this that contains the client or the connection reference and the parsed command on that queue. We could make it a record, or we could make it a tuple, so that we know that they're paired together. Maybe a connection ID and a command. Tuple. Something like that would let us know where the command's coming from. So that some internal part of the server that's processing the command can go, okay, cool, and I have some output for this connection, blah. And then, so once I have a connection ID, I know I can look up in state connections for that ID, get the connection, and then get its output queue I can put stuff on. So I think that's good. Makes sense. So let's go back to server. The client connection, that's fine. The types are quite right for init connection, that's right. Yeah, TQ, that's got to be updated here. There, yeah. So we're going to do something with the left. I don't know what yet, but now that we have that and all of this stuff, we can we can get the command queue. Server state command queue. And we should be able to put on it. Now, connection. You don't have your connection ID associated with you in your body. Talk's either going to need that, or we're going to have to put it, that data, that connection ID in the connection type. Let's try the passing as parameter. Can I do that? Let's see, talk. So init connection has to return. Okay, creates a connection ID there. Adds the connection ID to the map internally in the state. We just need it to also return that connection ID. So that we can put it there. 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 And now we can enqueue on our TQ. Is it right? Write a value to it. Flush, try, read, read. I guess right is NQ. So we write the TQ, the Q we want to write to, which is command Q, a value. All right, it's going to be our connection ID and our command. The type. So I missed that. Connection ID. Go. Okay. So in the case where we couldn't parse the command, or the parsing failed, we need to do something as well. And I'm thinking maybe we should also make that a kind of command that we can put on the queue, and something can handle those and write them back to the client and let them know. So that's kind of interesting because we add it to our command type. It's not really a command to the server, per se. It's more like a meta sort of thing. It's almost like we want another type, maybe, for these inputs. Like a client command or connection command. Or client command. Will have its connection ID, the command, well, maybe either the command or the command error. And then we can put those on the queue. So it could be a thing with the connection, sort of. Or it could be a part of the server client. This. We have a client command, connection ID, a client command. Client command. We call it a client input. And then we have complaint input command. And that one could be either a parse error or a command. Yeah, I think that's a little bit extra. A little bit extra that we might not need, actually. Let's try... It's the only thing... maybe it's not. I don't know. I'm going to flop on this a little bit around. And I might need to feel this out a bit. But I feel if we make it a command, it's... like, for parse errors. What would it be called? Maybe it should be... Well, maybe it does make sense. Maybe it should be like handle a parse error. I don't know. Maybe handle parser. But we don't have a parser for that. Right. Like a special case. So like normally in like the whole parse don't validate kind of thinking is that you, well, maybe this still kind of fits in though, like, but you parse and recognize your entire input, and you only construct values through your parser is the idea, really. And so you validate that your parser constructs the values in the way that's correct for your program assumptions. And that way the rest of your code doesn't have to worry about validating the input data because the parser validated it. The parser did that validation. The parser constructed the value in such a way that it is quote-unquote correct by construction. Correct by parsing. But now we have this one constructor that you're allowed to use without a parser. So I feel a little bit weird about that. All right, because what I'm going to put here, what am I going to put here? I got parse error. I don't even know what type parse error is at the moment. Let's see if I can expand this. Yeah, parser, error bundle, text, base void because we didn't define one. And I think we can do stuff with make a parsec to decode that error. To get a text. Error bundle pretty. Well, we get a string. Parser error bundle pretty parse error. Then we can TQ write TQ command Q connection ID, and this is where we have to manually construct our handle parser with an error message. queues. So let's bring that as queue in both cases. I'm going to pack that. And T in this module. Bring that up here. Yeah. And we can't even read from our reader, our Bakamud server in the STM context. So when we're running a transaction. Interesting. Okay, and now we're down to command dispatch. Okay. So all command dispatch has to do, right, is something. Maybe this should be where our main, like maybe our main server tick actually should be. Handing off of this, but this is where we need to start thinking about a little bit about the internal structure of our server loop. All right, so our server is sitting here waiting for things to happen. Let me grab my little pen so I can sketch along. Kind of sketch these ideas out. All right, so in the server, we've got these threads that get fired off for each of the connections that we raise along, and they are constantly reading input. All right, and what we've got now is a way for them to input their commands onto a queue for us to process. Okay. Some of these commands are things we want to have happen for that client immediately, like authenticating, quitting the message of the day, these commands that we've just come up with. And then there's the simulation loop. All right, so the simulation system is going to be, also needs to read from a queue of commands every tick. It's got to process all the commands it's got to process, update the state of the world, and then to publish all those updates back out to the clients that need updates for the respective connections, right? All right, so it's, most architectures use like a tick kind of architecture where like one trip around is like one tick, and one tick resolves one set of, like, almost like a static update to the world. So if you had input attack monster, and then when the tick resolves, it pops that command off. And then you might be in the middle of passing in another command, right? Or about to type one in or whatever. But the server is going to pop that command off, and it's going to resolve those. Now, the order in which these have to resolve has to be somewhat consistent, right? So that the effects of what you think has happened as the user, and you're imagining what you think is going to happen actually does happen, right? But the server's always running those ticks, and our commands are kind of over here. And we put them in a queue. Which does imply an order, right? First in, first out. So some of these commands we want to dispatch to command dispatch here and handle them right away and not interfere with the simulation because they have nothing to do with the simulation. And then we have commands that we want to pass on to the simulation to process, like in the tick, and to update the sim. So I think there's two different kinds of commands is what I'm thinking now at this point. And so the command queue here, and the ones we've come up with, I think unprocessed is actually like maybe everything that isn't like specifically a server command is a simulation command, and we can put that into a separate queue. Right. And everything else is here. And so our dispatcher can dispatch and process these normal commands, and then unprocessed or simulation command, it'll pass off to the MUD code for further processing, and in a separate input queue for that. I hope that makes sense. So for now, with command dispatch, what do we want to do? Let's just make it print off the commands it's got off the input queue and then wait for more input. That way we can just see that it's all kind of passing data through as we expect from the inputs of the clients. We can type stuff in. All right, so it's going to try and what do we want to do? Flush the queue, read the entire contents of the queue into a list. That could be a lot. We could try iterating over it until this is no longer true. Or until it is true. And just read a chunk of them at a time. Oh, I don't think we get chunks. We either get flush or read one. I guess we have flush. We have to give it, so we need the queue. And then each of the commands, just print them out. We'll just do print command. How do I don't need control.monad. Where's that come from? Google. Or is it 4M? Oh, yeah. 4M. And that means it atomically. That needs a lift.io. Interestingly enough. And Q should be used here. Oh, yeah, because we need to update the connection type here. Client. No, not you. Yeah, command Q needs to be, it needs to be there. That's why we passed it all the way through. Right? Or did I not need that? Maybe I don't need that. Maybe I don't actually need that. Let's get rid of it. Okay. So now, when we run the server, try this out. All right, port 3000. Welcome to Bakamud. We should start getting hello. Okay, if I try to type something, send it. It's not letting me type anything in. Okay. What do we need here to get these? Start getting the input. So when we receive on the socket, yeah, we should. telnet. Okay. Interesting. I wonder. Let me just turn off the simulation red for now. Let's restart the server. Let's connect to it. Okay. It's got the connection, it's waiting to receive input, but our telnet client isn't sending the data. I wonder if it's my telnet client. It's the telnet client's fault, or we're never getting into talk. Message received. Let's do a little debugging. Rebuild the server. That's going to be a problem because it's not a string, it's a byte string. I have byte string, import is S. Encode UTF-8. No. Search byte string to string. Haskell byte string. No, I think it's going to be like encoding or something. Car 8. Gotta have some kind of pack or is it pack? Unpack. There we go. Yeah, that should be it. Let's try that. No. Ambiguous. There we go. Okay, cool. Okay, we got message here. Okay, so something is blocking us from getting input. Okay, so we're going to need to fix that. But I think we're out of time on the stream. So I'm going to have to leave that as a to-do and make this a work in progress commit. Let's just put the simulation thread back on. Just a quick little review. So we added the command module, parser, dependency, and that means we're missing a file here. There it is. For that. Okay, the command module has our commands, message of the day, and the parsers for it. Command P. That's all well and good. And then we change the server state so that it has a command queue. We modify the server so that it, when it reads from the talk thread, when it receives data, a message, it tries to run the parser and put the command on the queue. And we have a dispatcher that reads from the command queue and just prints whatever it gets, whatever it flushes out of there. Okay. And dispatching. We'll simplify to add command handling. Added a command type. And a command queue, server state, changed, talk, tries to parse input and put into a command. Talk tries queue parsed commands. And dispatch thread. To-do. Input handling. Not working. With output. They seem to be blocking each other. So it's going to take some investigation to do, but that's good. All right, I'm going to push that up. So all the code that you've seen tonight for this project lives on GitHub. I'm Agent Ultra, and I'm also Agent Ultra on GitHub as well. And this is Bakamud. All right, Bakamud. It's our attempt to learn how if we can build a multi-user game server in Haskell, and yeah. So give it a star, give it a fork, give it a like, watch whatever, and you can follow the project there. You can also find me on the socials. I'm on the types.pl server, on Mastodon, in the Fediverse. I have agentultra.com as my website. And both of those things have links to my YouTube channel where I back up the VODs for this stream. My Twitch, my repositories, everything. You'll be able to find it through there. If you follow me on here, on types.pl, you'll find updates on when I'm streaming, projects I'm working on, and I like following new interesting people. So if you're also on Mastodon as well, reach out, give me a follow request. I'll probably follow you back. And go to the link above my head. That's declarative.tv. If you like what you saw today, you might like what you find there. There are other streamers who are doing things in languages like Haskell, but also Erlang, Elixir, and all kinds of declarative style programming languages. And there's also a link to a Discord server on that website as well, where you have a channel for this stream. So you can show up in the channel, talk about your projects, ask those questions you didn't get to ask live on the stream because you're watching on YouTube or whatever, or you just didn't think about it until the shower the next day or whatever it is. And you can ask the questions there and chat with the rest of us and hang out and have some fun. And that's about it. Oh, I do these streams once a week on Tuesday evenings, about 10 after 8 in the Eastern Standard Time Zone. So you can write that down, or you can follow me here on Twitch. Give us a follow, and you'll get if you have your notifications turned on, you'll get notified when I go online. And if you're watching on YouTube on the VODs, thank you. Give us a like, subscribe, thumbs up, leave a comment, and feed the algorithm. And that's about it. So thanks again for watching and tuning in. Happy hacking out there. May your monads be free and your types check. And we'll see you next time.